there, in this video, we are using completing the square method to factorize the quadratic expression. And what kind of the question this time we are focusing is, so as we know that the quadratic expression looks like ax squared plus bx plus c. So we see that now this is the quadratic expression. In the previous video, we talked about the ones where we have got a equals to 1. But in this video, we are doing a quadratic factorization, but using a completing square method, completing square method when a is not equals to 1. So a could be any number than 1. It could be 2, 3, -3, or could be any number. So let's have a look to the first example, that how we can factorize the quadratic expression by using the completing square method when x squared coefficient is not 1. So having a look to the first example now, we are having 2x squared, so 2x squared plus 6x plus 3. Now we see that because the x squared coefficient is not 1, we try to do, what we're going to do, the first step is to factorize 2 from each of the term. So initially we see that 1, 2 and 3, we have got 3 terms here. We take 2 outside from each of the term. So when I take 2 outside from the first term, I would be having x squared. How many 2 makes 6 would be 3, and there's a x. We cannot straight factorize 2 from the last term. So we'll be writing it down 3 over 2 then. So this is the first step where I have factorized 2. Now, because we have factorized 2 now if I look to the first term now, it's going back to the type 1. Now, this is exactly what we have done in the type 1 factorization by using a completing square method. So now we have got the x squared coefficient is 1, and we'll be using now the completing square method on it. So we're going to start by making a bracket, which is x plus half of x coefficient. So we always do the half of the x coefficient. So here the x coefficient is 3. When you do the half of it would be 3 over 2 square. We always use the negative sign here, negative and the square of the second term. So here we have got the next term written as 3 over 2. We do the square of it. And then whatever the third term is, which is 3 over 2 here. We close the bracket because we have got 2 written outside the bracket, which will multiply with each term written inside the bracket. Now, we keep the 2 remains outside. We do the simplification inside the bracket. So, x plus 3 over 2 whole square minus, when you expand it out, would be 9 over 4 plus 3 over 2. Now, we're going to simplify these two fractions where we're having minus 9 over 4 plus 3 over 2. I'm going to write this down on the side and do the simplification. So, if we are having minus 9 over 4 plus 3 over 2, we'd make the denominators to be the same. We'll be having 4 as a common denominator and then minus 9 plus 6. So when you do minus 9 plus 6 would be minus 3 over 4. So the simplification of these two fractions would be a single fraction as minus 3 over 4. We'll close the bracket here. Now we are having 2 outside the bracket. We are having a bracket x plus 3 over 2 square, and then it's minus 3 over 4. Now what do I see that we have got 2 written outside the bracket, which is going to multiply with both the terms written inside the bracket. So it's going to multiply out with this one as well as with the next one. Now when we expand it out, we'll be having 2 bracket x plus 3 over 2 square minus, then it would be 2 times 3 over 4. Because you're having 2 times 3 over 4, you can simplify them together. So this would be 1, this would be 2, because the relation between 2 over 4 would be a half. You write down the last step now, which you write down 2, x plus 3 over 2 square minus 3 over 2. So this is the factorization of 2x squared plus 6x plus 3. I'm going to show you now with the next example, but before we go on to the next example, as I said that sometimes they can ask to find out the maximum point, or they can use the word the minimum point, or this is that find out the turning point coordinates. So to find out the turning point coordinates, first of all, repeating that coordinates means having the x value as well as the y value. So we would be looking for something in terms of x and y. I'm going to use the next one now. So what we have got the answer, which is 2 bracket x plus 3 over 2. I'm going to write it down as y equal to 2 x plus 3 over 2 whole square, and we are having then minus 3 over 2. So we're having then minus 3 over 2. Now I'm finding out the turning point coordinates for this. We're going to start with the bracket. So we're having this bracket. We need to find out the x value, which makes the bracket equals to 0. So we are trying to make the bracket equals to 0. So we'll be taking now, to take the bracket equals to 0, we are taking x equals to minus 3 over 2. So it's pretty obvious that if we take x equals to minus 3 over 2 and we're having plus 3 over 2, so it would simplify and make it equals to 0. So if I take the x value equals to minus 3 over 2, then I would have the y value equals to minus 3 over 2, because 0 times by 2 would be 0. And from 0, if you do minus 3 over 2, you'll come out with minus 3 over 2. So the coordinates of the turning point would be minus 3 over 2 and minus 3 over 2. These are the turning point coordinates. I'm going to show you one more example now. Here's the next example. So here's the next example where we're having 3x square. So this is going to be 3x square, and then we are having minus 18x and then minus 1. So again, we're going to start. Here we see that the x square coefficient is not 1. So we try to make it 1 by factorizing 3 outside the bracket. If I try to factorize 3 outside the bracket, then we are having x square minus, how many 3 makes 18 is going to be 6x, and then minus 1/3. Because I cannot take 3 as a factor from 1, so I'll be having then 1/3 here. Once we get to the stage where we're having the x square coefficient equals to 1 now, what we can do now is we're going to apply the simple factorization by using the completing square. So we are keeping the 3 outside the bracket. This 3 remains outside the bracket. Here we do x minus half the middle term would be 3 square. Then there's always a minus sign here. Then whatever the second term, you do the square of it and then minus third. We're going to do the simplification part. Once we finish the simplification, then we're going to expand it out. So x minus 3 square, this would be minus 9 minus 1/3, and we're going to simplify now. So if we're having minus 9 minus 1/3, we make the denominator to be the same. So times by 3 with the top and bottom. We are having minus 27. There's a minus 1 and the common denominator is 3. You'll get minus 28 over 3. So we are having 3 outside the bracket now, so which is going to be here. Then inside the bracket is x minus 3 whole square. Then the simplification of minus 9 minus 1/3 would be minus 28 over 3, which I'm going to write down next now. So it would be minus 28 over 3. Now, once we do the simplification inside the bracket, we're going to expand out the bracket with this 3 written outside the bracket. So this 3 we're going to multiply with the first term, as well as is going to multiply with the next term. So now we are having 3 bracket x minus 3 whole square, and when you multiply it out between, there's a minus sign. That would be 3 times 28 over 3. The top and the bottom 3 would simplify each other. And the next step would be 3 bracket x minus 3 square minus 28. This is how we can do the factorization of 3x square minus 18x minus 1 in the completing by using a completing square method. I'm going to show you now how would you find out the maximum point coordinates from here. So to find out the maximum point coordinates, what you need to do is we're going to write it down with y equals the whole thing. So now we are having is y equals that would be 3 x minus 3 square minus 28. So this is what we had before. Now we are finding out the maximum, or because we are having we are finding out basically the minimum point coordinates. So we'll be getting minimum point coordinates from here. To find out the minimum point coordinates, we are looking for the x and the y value. We're going to start that what x value we're going to make the bracket equals to 0. So because there's a minus 3 already, if we take x equals to 3, then we'll be getting 3 minus 3 whole square would be equals to 0. So if I take x equals to 3, then whole bracket of this would be turning to 0. And when you do 0 times 3 would be 0. And then from 0, when you minus 28, you'll get y equals to. So from here, you'll get y equals to minus 28. So the minimum point coordinates that you'll be getting would be 3 and minus 28. Now we're going to look to the last example of this completing square, factorization by using the completing square. In this one, we are having 4x squared minus 8x plus 9. We're going to begin by factorizing 4. So when we factorize 4, we'll be getting x squared. How many 4 makes 8 would be 2x plus, remember that because we can't factorize 4 from 9, then we're going to write down 9 over 4 here. Once we have got the 4 as a common factor, what do I see that now? We are having the x square coefficient as 1, so we can apply the completing square method here. So we are applying the completing square now. So to begin with applying the completing square, we have got 4 outside the bracket. We do x minus half the coefficient of x, which would be half of 2 would be 1 square. Then there's a minus 1 square, and then there's going to be plus 9 over 4. We're going to do the simplification inside the bracket. So we're keeping x minus 1 whole square the same. Then is minus 1 plus 9 over 4. On the side, you can do the fraction simplification. So minus 1 plus 9 over 4 means you make the denominators to be the same. The top and the bottom needs to be the same. So it would be minus 4 plus 9 over 4. That would give 5 over 9. So you'll be getting now 4. There's a bracket x minus 1 square, and the simplification of these two fractions would be plus 5 over 9. So I'm going to write it down over here, would be plus 5 over 9. You're going to expand out the bracket to do the more simplification now. So you open up the bracket, so 4 times x minus 1 square plus, when you open them up, so you multiply these together, 4 times 5 is a 20, and you'll get 20 over 9. Oh, it's 4 in the denominator. So that you'll be getting 20 over 4, and you multiply by and you simplified more. So how many 4 makes 20 would be 5. So you'll get just 5 here. Now, even with the same one, you can find out the minimum point coordinate. So I'm going to write down my completing square form, which is written in the form of 4. And then we are having, I'm going to write it down 4x minus 1 square plus 5. So now we are finding out the minimum point coordinates. So minimum point coordinates, we're going to start with taking what makes the bracket equal to 0. Which x value we're going to make the bracket equal to 0. Taking x equals to 1 would make the bracket equals to 0. We'll be writing this now y equals to. Because taking x equals to 1 will make the whole bracket equals to 0. And you do 0 times 4 would make still 4. So you will get the y value from here would be just 5. So you'll be getting 5 as the y value if you're taking x equals to 1. So writing them down in the point coordinate form would be 1 and 5. So the video is all about how to do the quadratic factorization by using the completing square method, and even we have looked how to find out the minimum point or the turning point after the factorization.